This is the first video in an introductory series on statistics that starts with the topic of random variables. The series is built on the idea of teaching quantitative subjects using a real dataset based around one particular interest, in this case a sport. In this video, the interest is the sport of mixed martial arts, and the dataset will be based on the data gathered from events in the UFC. The UFC has developed a rich dataset, including metrics like striking accuracy, takedown performance, and much more, which gives us a launching pad to teach all the ideas and concepts in introductory statistics in a relatable and engaging way. Many popular sports have large datasets that can be used in quantitative courses as an aid to explaining mathematical concepts, and these sports will be explored in future videos. This idea can be extended outside of sports to any interest that can be quantified. The topic of this explainer video is random variables. An often overlooked component of introductory statistics, random variables are crucial for bridging things that happen in the real world into the world of mathematics. We will start with an informal definition of random variables. Random variables take things happening in the real world and convert them into numbers. They are the conversion tool needed to take our observations of the world and quantify them according to a set of rules that allows them to be used by mathematical tools we have already developed. An example of a random variable is the total number of strikes landed in a standard UFC event. If a UFC event occurs and the end result is that 50 strikes were landed, we could define the total number of strikes as the symbol SL and record its output for this fight as 50. SL is the actual random variable, while 50 is the output or result of the random variable for this specific fight. A random variable takes something that happened in the real world as its input and converts it to a number. In this example, the number 50. While we might have a rough idea of what the value for the total strikes landed might be, we wouldn't be confident guessing on any specific number. The outcome of the fight is random and unknown to us before the fight begins, and we don't know exactly what the total number of strikes thrown will be. If we want to think about what this number might be in a meaningful way, we need to start with a method that describes the real world, and then assigns numbers to this description. We will then be able to start to reason about the likelihood of different events occurring in the future. That might sound simple, and in a sense it is. Random variables process the world around us into numbers that we can analyze more easily. But the means by which they process the world around us is more technical, and this is what we will explore next. But first, let's create a sample dataset for use in this video. Let's define some random variables that describe the outcome of a UFC event and create some fight data using them. For the purpose of this video, we will include 2 different data points for the performance of each fighter, giving us a total of 4 data points that describe a standard UFC event. This table holds the data for each fight, with each number in the table representing an output from either the random variable RS, RT, BS, or BT, across 6 different UFC events or observations, labeled from A to F. Now we have our data, let's formally define a random variable and explain each term in the definition. A random variable is a function that maps members of the sample space to real numbers in the state space. Random variables are functions that connect each of the possible outcomes of a UFC event to a meaningful real number that we can use for analysis. In this diagram, W is a member of the sample space omega that has been mapped to a real number in the state space by the function x. An example would be the random variable we defined called RS for total strikes landed by the red corner. This is a function that maps each of the outcomes of the fight, W, to a unique number in the state space that represents to us the total strikes landed by the red corner. Let's expand on the term sample space. The term sample space refers to all the possible outcomes that can occur in a probability model. A UFC event is a random process, and the results such as total strikes landed, method of finish, and the winner are the outcomes of the sample space. The omega symbol represents the sample space, and W refers to one of the many possible outcomes in the sample space. A sample space is part of what's called a probability space, which is a mathematical construct with 3 rules that define the sample space, the event space, and the probability measure. We will look into probability spaces in further detail later, but for the purposes of this video, we will just keep in mind that the term sample space is used as per its definition within a probability space, which is just a set of rules describing random processes in the real world. A sample space holds all the possible outcomes of a random experiment, and each time the experiment is performed, we refer to this as an instance of the experiment. An instance selects one outcome, W, from the sample space, and we say that this outcome has occurred. What is important for us to remember is that we define what can occur in a UFC event. Many strange things can occur in MMA fights, but for the purpose of simplicity, we have defined our sample space using the previous dataset, where the outcome represents a given number of strikes and takedowns by each fighter. Now we will explain the term function in more detail and how it connects the sample space we have defined with real numbers. The term function refers to a process in mathematics that takes an input and transforms it in some way into a distinct output. Functions can take data and transform it according to a set of rules, or an equation. Converting between currencies would be an example of a function, as it takes an input in the form of one currency and produces an output representing a different currency based on a given equation, in this case an exchange rate formula. In the context of UFC data, a function could be used to produce a value for striking frequency by dividing the total strikes thrown by the total length of the fight. When we examine our UFC dataset, we can see that each number is the output of a random variable in the form of a real number, and in this case, 60 is the output of the random variable RS for strikes landed by the red corner. The input for this function is the element of the sample space that is said to have occurred, W, and the function is a process that transforms this output based on some set of rules into the numerical output we see and use in data analysis. This output is what's called a real number, which are the rational and irrational numbers. Random variables are functions that convert the outcome of a random experiment to real numbers that we can use for practical data analysis. Random variables allow us to quantify the real world.